Welcome back to Nature and Code in Rust and GGEZ. We're moving on to example 1.4, multiplying a vector. So for this example, we'll see, it's right down here. We're going to be doing exactly the same thing as last time, except we're going to be multiplying the line by 0.5. Or divided in half, exactly the same, whichever way you think of it. Basically cutting the line in half as it's pointing towards the mouse. Let's go ahead and get to it. So the first thing we're going to want to do is set up our multiplication here. So I'm going to go to our utilities, our vector, and we're going to add in the ability to multiply. And I also want the multiply assign. So let's see. We're going to impl t mul for a vector 2 t, where t is a num, also a copy, and a mul assign. No code actions. What did I do wrong? No colon. There we go. Okay, so type output equals a vector 2 of t. We have a right-hand side here. Okay, so now this is going to be interesting, actually. So when we're doing multiplication here, it's talking about having a scalar come in. And this is basically having the right-hand side be self. That's not really exactly what we're looking for here, isn't it? We really want to multiply for, let's see, the t coming in vector 2. I don't know if we can do this because the output is going to be a vector 2. That's definitely true. But I can't set this to be something like where a t is going to be brought in, because that's going to say, hey, it has an incompatible type for this trait. So I don't think we can actually do this. So instead, unless I was able to use something else, I think we can. So we're going to have to actually do this inside of our normal impl. So we have this pub function to array, we have new, and so here we're going to have, I'm going to call this multiply scalar, just to make sure it's extremely explicit in what we're doing. So first of all, we're going to allow dead code. Although in this case, I don't know if it matters that much. So we're going to do a pub function multiply scalar. Take immutable reference to self, and we're also going to take the scalar. This is going to be a t, and we're not going to return anything. What we're going to do is we're going to say self.x times equals our scalar, self.y times equals our scalar. And that's it. That's going to be our multiply scalar. Now, what are you upset about? Binary assignment operation cannot be applied to type t. Okay, so we need the times equals to be added to this. So num plus copy plus mul assign. And there we go. Okay, so we're happy here now. We can now go ahead and do the rest of our code. So we're going to head over to our main library. And we're going to do all the things. So to begin with, we're going to need, let's see, we're going to need our center point. We're going to need our line. Our center point should be, we could create that just right at the beginning. So we can have a center point. We can just call this maybe center. We can be a vector 2. That'll hold an F32 inside. What else do we care about this? I don't know if we need anything. You know what? Let's have the scalar that we multiply by being here too. That's going to be our scale. So have our scale, which is an F32. And I think that's going to be it. When we create this new, we're going to create our center. So we need our width and our height equals graphics, drawable size, pass the context. And then our center equals a vector2 new with width divided by 2, height divided by 2, and then we need our scale. So let scale equals 0.5. It's easier to, in my mind, it's easier to do scaling by multiplication. Like division is pretty much the same thing as multiplication. We just change it around. In my mind, it's easier to sort of like see it as multiplication. Then we're gonna store our center and store our scale. All right, so we're happy here. Now in update, oh, we also need our mesh. So we're gonna have this be an option that holds a mesh. So you're gonna start with a none here. All right, so in our update, we need to update our mesh based upon where things are coming in. So the first thing to do is to get the mouse location. So we can get the mouse position pretty easily, but then we actually want to give ourselves an actual like mouse location. You know what? I'm actually going to create a new utility for this. So new file in here. What do we want to call this? This should be like mouse location. So mouse rs hub mod mouse. Okay, so we're gonna have mouse location. You're gonna take in I believe we need the context. Immutable reference to a GGEZ context. And I believe we can return a result. Now this can be an error result. If we do that though, we're gonna have to do an unwrap at the beginning, and here we are returning a game result. So I'm gonna make this a game result that we return. And inside we're gonna return a vector2. With a F32 inside. All right, so first off, let's get that mouse location. And the context, and do you just give me that? You do. It's not even a result. It just gives me that. So maybe I don't even need a result. Maybe I can just return the vector2. All right, so we're going to return a vector2 new, and we're going to give it the mouse location.x and the mouse location.y. So this is a nice little wrapper around the API for mouse location to give us the type of vector that we really want to get. So when we come back to here, in update, we can get our mouse location. So let mouse equals, what do we call this? Utilities. There you go, mouse location. Pass it in this context. And there we go. We have our mouse location. We also have our center location. So what we can do is we can subtract the mouse. So let's mutate this, and then we can say mouse minus equals self.center. And let's see, okay, that gives us that. Then we want to multiply the mouse. So we want to say mouse dot multiply scalar by self.scale. And then we want to create our mesh. So our points are going to be between 0. So points equals, our first one is 0. And our second one is going to be the position of the mouse. So mouse.toArray. And then we can create our mesh. So self.mesh equals sum, a mesh builder, new line, a reference to the points. We'll make this width, white. We're going to question mark that, then build, and the context, question mark that, and that should give us the actual mesh. And there we go. Okay, that should be happy. We're done with update, and then we want to actually draw this out. And if we remember, we do have to translate here. So we have to do graphics, apply transformation, no, set transform, and the context. This is going to be a draw param, new, and then we set a destination. Now the destination is based upon the center, which is the halfway dest, which is simple for us because we could just do a self.center.toArray, and that should set our transform. And at the end, we're going to do a graphics apply transformations, handle the context, handle the error. And then in the meantime, we can then draw things out. So if let some mesh equals a reference to self.mesh. So if we have a mesh, then we're going to do graphics draw, hand it the context, hand it the mesh, and hand it an empty draw param. Come on, draw param. There you go. New, and handle the error. There we go. Let's see. Oh, you're not happy. What's the error message? Oh, right. We have our draw param, and I forgot that at the very end, we have to do an into to matrix. That should make it work. Now let's run this. And now our we have that point from the very center halfway to the mouse. But otherwise, it acts exactly like the last example 1.3. And that's how we do multiplying a vector. Thank you for watching so much, and I will see you in the next video. Bye.